Have you ever felt the crushing frustration of information slipping through your fingers like sand? That crucial detail for an exam, the name of a new client, or even the location of your car keys, all vanished into the ether of forgetfulness. We've all been there, battling the elusive nature of memory, often resorting to brute force repetition that yields only temporary, fragile results. But what if I told you that memory isn't a fixed trait, but a dynamic, trainable system, governed by precise neurological principles? What if there was a neuroscience-backed trick, a genuine mental hack, that could fundamentally transform your ability to remember anything, potentially forever? Forget the old adages of just trying harder. See, your brain isn't a passive recipient of information, it's an active constructor of reality, constantly forming, pruning, and strengthening connections. The challenge isn't a lack of capacity, but often a lack of understanding regarding the brain's preferred methods for encoding and retrieving data. We're not talking about simple rote memorization here, which barely scratches the surface of your cognitive potential. We're delving into the deep architecture of your mind, exploiting its inherent biases and evolutionary adaptations to forge memories that are robust, resilient, and readily accessible. At the core of this transformation lies an understanding of how our brain actually processes and stores information. Our memory isn't a single entity, but a complex interplay of systems. We have sensory memory, fleeting glimpses of our immediate environment; working memory, our mental workbench where information is temporarily held and manipulated; and then the grand repository, long-term memory. Within long-term memory, we distinguish between explicit memory, which deals with facts and events, and implicit memory, which governs skills and habits. When we talk about remembering anything, we are primarily focused on enhancing explicit memory, specifically semantic, facts, concepts, and episodic, events, experiences, memory. The hippocampus, a seahorse-shaped structure nestled deep within your temporal lobe, is the orchestrator of explicit memory formation. It acts as a kind of temporary holding and indexing system, consolidating new information from working memory into long-term storage across various cortical regions. The prefrontal cortex, on the other hand, is crucial for working memory and the strategic retrieval of long-term memories. The issue with conventional learning methods is that they often fail to adequately engage these critical brain regions in a way that promotes deep, lasting encoding. Repetition alone can be superficial. It creates weak, easily disrupted neural traces. To remember anything forever, or at least for a significantly extended period, we need to leverage the brain's natural mechanisms for forming strong, resilient synaptic connections. The neuroscience trick we're about to explore isn't a single magic bullet, but a powerful synergistic approach built on two fundamental pillars: elaborative encoding and the strategic exploitation of our brain's innate spatial memory capabilities. Elaborative encoding is the process of actively connecting new information with existing knowledge, making it meaningful, multisensory, and emotionally resonant. It transforms inert data into a rich, interconnected web within your neural network. Think of it as building a complex, vibrant neural structure instead of just stacking loose bricks. The scientific basis for this lies in synaptic plasticity, the brain's ability to strengthen or weaken connections between neurons over time. This phenomenon, often summarized by Hebb's law, neurons that fire together, wire together, is the molecular bedrock of learning and memory. When you engage in elaborative encoding, you're not just activating one neural pathway, you're triggering a cascade of interconnected pathways, strengthening multiple synapses simultaneously. This widespread activation creates a more robust, redundant network for the information, making it less susceptible to decay. Long-term potentiation, or LTP, is the persistent strengthening of synapses based on recent patterns of activity. Elaborative encoding directly promotes LTP by ensuring that new information is processed deeply and connected broadly, leading to more frequent and synchronized firing of associated neurons. The more connections you make, the more hooks you create for retrieval, and the more resistant that memory becomes to forgetting. Furthermore, our brains are exceptionally good at processing spatial information. This isn't a coincidence, it's an evolutionary imperative. Navigating our environment, finding food, and remembering safe havens were crucial for survival. This has endowed us with highly developed neural circuits dedicated to spatial memory, primarily involving the hippocampus and parietal lobe. By consciously linking new information to a spatial context, we tap into this ancient, powerful system, giving our memories a robust, inherent structure. This is where the venerable method of Loci, or memory palace, finds its neuroscientific justification. It's not just an old parlor trick, it's a sophisticated technique that hacks into your brain's natural processing strengths. Let's dive into the practical application of this neuroscience trick. It's a multi-step process, but each step builds upon the last, creating a powerful mnemonic system. Step 1. Deep processing and semantic encoding. Before you even attempt to memorize, you must deeply understand the information. Don't just read it, interrogate it. Ask yourself, what does this mean? Why is it important? How does it relate to something I already know? Can I explain this in my own words? Engage your prefrontal cortex in active analysis. Visualize concepts, draw diagrams, or create mental models. For instance, if you're learning about dopamine, don't just memorize dopamine is a neurotransmitter. Instead, envision its molecular structure, recall its role in reward pathways, think about how it makes you feel when you achieve a goal, and connect it to conditions like Parkinson's disease or addiction. The richer the semantic network you build around the information, the stronger its initial encoding. Step 2. Leveraging spatial memory. The memory palace. This is the cornerstone of making memories forever. Choose a familiar, detailed location. Your childhood home, your current apartment, your daily commute route. This will be your memory palace. Now, identify distinct loci, or locations within this space. The front door, the hallway coat rack, the kitchen counter, the living room couch, a specific bookshelf. The key is that these locations are vivid and ordered. Once you have your palace, transform the information you want to remember into vivid, bizarre, or emotionally charged images. The more outlandish, multisensory, and interactive these images are, the better. Then, place these images at specific loci within your palace, mentally walking through your chosen route. For example, if you need to remember a list of historical dates, imagine a prominent figure from that date performing an absurd action at your front door. If it's a scientific formula, visualize its components interacting wildly on your kitchen table. The hippocampus loves novelty and spatial relationships. By anchoring abstract information to a concrete, familiar spatial framework, you provide a powerful retrieval cue that your brain is hardwired to process efficiently. When you need to recall the information, you simply take a mental stroll through your memory palace, encountering your carefully placed, vivid images. This engages both your visual cortex and your spatial navigation system, creating a multimodal memory trace. Step 3. Storytelling and association. Our brains are natural storytellers. We remember narratives far better than isolated facts. Once you have your individual pieces of information encoded vividly and placed within your memory palace, weave them into a narrative as you move from locus to locus. Make the images interact. If your front door has a historical figure and your coat rack has a scientific formula, imagine the historical figure struggling to put on a coat made of the formula. The more illogical, humorous, or dramatic the story, the more memorable it becomes. This step further strengthens the connections between the individual pieces of information and their spatial anchors, creating a cohesive, easily retrievable schema. Step 4. The power of chunking. Cognitive load is a real limitation. Our working memory can only hold a limited number of items, typically 4 to 7, at any given time. Chunking is the process of grouping individual pieces of information into larger, more meaningful units. This effectively bypasses the working memory bottleneck. Instead of remembering 7 individual letters, remember one acronym. Instead of 7 numbers, remember a phone number. When applying this to your memory palace, group related pieces of information and assign the chunk to a single locus. For instance, if you're learning about the parts of a neuron, chunk the dendrites, soma, axon, and myelin sheath into one composite image at a single location, perhaps a miniature, glowing neuron dancing on your desk. This reduces the number of loci you need and makes the overall process more efficient. Beyond the initial encoding, true forever memory requires intelligent consolidation and retrieval strategies. Optimizing memory consolidation. Spaced repetition. This is a non-negotiable hack. Hermann Ebbinghaus famously described the forgetting curve, illustrating how memory retention drops sharply over time, if not reinforced. Spaced repetition directly combats this by scheduling reviews at progressively longer intervals. You review information just as you're about to forget it, which forces your brain to work harder, strengthening the neural pathways. Tools like Anki or apps built on spaced repetition algorithms are invaluable. This isn't rote repetition, it's strategic repetition, timed to optimize synaptic strengthening and long-term potentiation. Active recall. Ditch passive rereading. The testing effect is a robust psychological phenomenon showing that actively retrieving information from memory significantly enhances its long-term retention. Instead of simply reviewing your notes, quiz yourself. Try to explain concepts aloud without looking at your materials. Use flashcards. Simulate the retrieval process you'll need in a real-world scenario. This active effort solidifies the neural pathways associated with retrieval, making the memory more accessible. Sleep's crucial role. Memory consolidation isn't just a waking process, it's heavily reliant on sleep. During slow-wave sleep and REM sleep, the hippocampus replays recent experiences, transferring memories to the neocortex for long-term storage. This process prunes unnecessary connections and strengthens essential ones. Deprive yourself of sleep, and you actively sabotage your memory formation. Aim for 7 to 9 hours of quality sleep to allow your brain to perform its essential memory housekeeping. Nutrition and brain health. Your brain is an energy-intensive organ, and its performance is directly linked to what you feed it. A diet rich in omega-3 fatty acids, found in fatty fish, antioxidants, berries, dark chocolate, and B vitamins supports neuronal health and neurotransmitter function. Stay hydrated, as dehydration can impair cognitive function. Think of it as providing the optimal biochemical environment for your neurons to fire and wire effectively. Common pitfalls and how to avoid them. Information overload. Don't try to cram too much into your memory palace at once. Start small, build gradually. Respect your working memory's limits. Lack of focus, distraction. Memory encoding requires focused attention. Multitasking is a myth. It's rapid task switching that fragments your attention and hinders deep processing. Eliminate distractions when you're encoding new information. Passive learning. As mentioned, rereading is often ineffective. Be an active participant in your learning process. Inconsistency. These are skills. They require practice. Don't expect instant mastery. Consistent application of these techniques will yield compounding returns. The forever aspect of memory isn't about perfectly preserving every single detail without decay. That's an unrealistic expectation. Instead, it's about building such strong, interconnected, and regularly reinforced memory traces that the information becomes deeply embedded and highly resistant to forgetting. It means that even if a specific detail fades, the overall context, and your ability to reconstruct that information remain robust. By continuously engaging with the material, revisiting your memory palace, and actively recalling information through spaced repetition, you ensure that the neural pathways remain active and strong. Memories are not static files. They are dynamic constructions, re-encoded and strengthened each time they are retrieved. Mastering your memory isn't about being born with a photographic mind. It's about understanding the neuroscience of how your brain works and deliberately applying strategies that align with its natural mechanisms. By embracing elaborative encoding, leveraging your innate spatial memory, and optimizing consolidation, you can fundamentally transform your ability to learn and retain. This isn't just about remembering facts. It's about unlocking your cognitive potential and enriching your intellectual life. Your brain is an incredible machine. It's time to learn its operating manual. If this perspective shift resonated with you, leaving AI like helps us bring more neuroscience-backed content to your feed. Joining the VF Growth Tutorials community ensures you're equipped for the next deep dive into cognitive performance. I'm curious, which of these strategies feels most game-changing for your routine? Let's talk about it in the comments. And if you know someone struggling to retain what they read, passing this along could be the breakthrough they need. Finally, don't break your focus now. YouTube is suggesting the perfect continuation to this lesson right on your screen. Click that next to keep building your cognitive toolkit.